Good afternoon, everybody. Good afternoon, everybody. Some people who are joining online, can you hear me?
Yes, we can hear you.
Okay, thank you. And keep yourself muted. And give attention, please. Good afternoon, everybody. So you see my screen, right? Okay, so let us start our lecture this afternoon. Today is September 1st, right? Okay, so let us see our schedule first. So according to our schedule, we are in this week 3. Okay, so in this week we will discuss module 3 selection structure. Okay, and there is an important reminder that so we are having our test 1 that will be on September 14th, but we have not decided yet that when it will be up and how the format. So in our next meeting next week we'll decide, and I will announce it on D12. Okay, so as I informed you earlier, so there is no makeup test. If you miss a test, there is no makeup test, and your final exam will automatically make that up. Okay, so but if you take all tests, then your final exam will replace the test, missing test. So final exam will replace the lowest test rate, right? If your final exam is better. But if your final exam is the lowest one, nothing will happen. So please keep your eyes that you will have your test, and according to our syllabus description, you have to have a webcam. Even we conduct our test, take your test over here in this classroom, you need to have a webcam and your laptop. Okay, so that is the requirement in this syllabus I discussed. So today we will discuss module 3. So according to module 3, these are the slides for module 3. Okay, there are 2 slides, actually 1 slide. Okay, but before I go to module 3, so in module 2 part 2, okay, I skipped, if you remember that, I skipped 1 slide. So module 2 part 2, so data type and expression. We discussed data type, right? There are 8 primitive data types, and we discussed these operators and their precedence. We discuss incremental and decremental operators, and we discuss assignment operators. So we discuss these, we discuss assignment operator, and 2 types of data conversion. Okay, data conversion. Okay, one is called widering. Okay, another is called narrowing. Okay, so sometimes we need to convert data from one type to another type. I will discuss this one. Okay, so later. So the way of conversion is that like assignment operator and promotion and mainly casting. Okay, then I skip this last slide, casting, typecasting. So it says explicit typecasting, right? So that means maybe there is also implicit typecasting also. Okay, so implicit means that happens automatically, and explicit means we have to force it to become. So explicit typecasting is the syntax. The syntax is like this. So for instance, you have an expression that has any type, and if we convert the value of this expression, an expression will give us a value, right? Finally it will give us a value, and if we convert the expression to another data type, that is called typecasting. Okay, typecasting, in order to remember typecasting, we need to remember 3 things. First of all, typecasting is explicit casting, and it is a temporary casting, temporary type sense. Okay. Second thing, that it happens on the fly. It happens on that statement only, and it will not persist. Okay, and there another rule I will discuss this one. Okay, so this is a few lines of statement, but let me go with an example. So I think I have a better example with this is Eclipse, right? I have this program also. So let us run this program in Eclipse, and then what is this? Okay. So for instance, I have some values. So if I say 49.0 divided by 10, so what will be my output? If I say y equal to 49 divided by 10, easy. What is the output? Y will, yes, 5.9. Thank you. So 5.9. Okay, so this is a decimal number. Okay, but if I am happy with, if I need to convert this 5.9 into a whole number, so the 5.9 is convert this decimal number, okay, into an integer number, that if the result 5. So if I do this, if I convert the value of y temporarily, okay, this conversion is here. This is called typecasting. So the format is that, as I discussed a second ago. So in which format, with type I will convert, I will enclose that type within square bracket. So this, there is a little bit variation in language to language, because some languages require that data type should be open, and then the expression or value needs to be enclosed with parentheses. Okay, some languages require that data type needs to be parenthesized. Okay, so here with the languages we are discussing Java, C++, and C#, almost same. So we are in converting this type. So y at this point, y was 5.9, and then if we say int y, then it will be 5. Okay, so not, as we know that 5.9 is very close to 9, right? 5.9 is very close to 9, right? So it will not take floor or ceiling, it will take exactly, so the integer part. So it has integer part is 5 and decimal part is 9, right? So then it will take only 5 if it says integer. Okay, so then actually happen, what will happen, then my question is that what will happen if I print y again? The result will be 5.9, not 5, because the conversion I made here, that is a temporary conversion. Okay, typecasting is temporary conversion. It happens on the fly and exists only on that statement. Do you understand? Remember that it will not persist for a long time. Okay, it will happen only that time. So this is called actually okay, so this is casting. Okay, so in this it should be very simple, right? Let us see another example. For instance, we see g equal to int g equal to 20 divided by 2 module 4. So what will be result? So 20 divided by 4, so division operator has higher priority or precedence than the modulus operator. So it will get this 20 divided by 2 equal to 10, right? 10 modulo 4 equal to 2. So we have got g equal to 2. But now if you want to convert g in either in float or double, then we can convert this way. Okay, g equal to, we are converting here, we are typecasting, converting that g that was initially 2 to float, and the float actually will give same result, 2.0 and 2.0, because okay, float and double will give same result. So this is straightforward, right? Anyone has any question? Okay, this is straightforward. Okay, now there are two types of casting. One is called up casting, another is called down casting. Okay, up casting is easy. Up casting is easy and it happens automatically, and there is no issue. Most of the time there is no issue for up casting. Okay, but down casting has some issues. So let us see. So here there are some variables here. First of all, number is like, this is a built-in type. This is called wrapper class, built-in data type, not in primitive data type. This number is built-in type. Okay, so it is built-in in Java, also in C# there is built-in type. So is n1 and n2 are two number types, and integer also integer type I, and D is a double type, so we have values. So these few statements are straightforward, right? We don't see any issue, right? It's very straightforward. Like actually these are like as follows. Okay, so if we have this, so we know that real number system, right? We know real number system. So that goes negative infinity to positive infinity. So these are all our numbers. Okay, real numbers. So it goes negative infinity to positive infinity, right? So you are familiar with real number system from your math, right? So in real number system there are many numbers. Some numbers are integer numbers, right? Some numbers are, for instance, it has some numbers that are integer numbers. Integers, and some numbers are decimal. Okay, there are other types of numbers as well as. So among integer numbers, maybe there are variations. Some numbers are prime numbers, some numbers are even numbers, some numbers are odd numbers, right? We know that, right? There are other variations. And for decimal numbers, maybe some numbers are float and some numbers are double, right? We understand this, right? This subset. So all of this integer number is a subset of numbers. So the decimal number or float or double are subset of numbers, right? Yeah, please be cooperative and say yes or no. If you don't understand, then I have to recap. Okay, you need to give attention, please. So you see that when we make a line, for instance, we draw a line like this. So you go to upward. If we go to the upcasting, so if you go an arrow upward. Okay, you see that all integer numbers are numbers, right? If you go upward, and then if we go upward, then all what we see, all decimal numbers or all float numbers are numbers. All double numbers are numbers, right? So upcasting, this is called upcasting. So upcasting is obvious, there is no doubt. So you see that upcasting is easy and then automatic, it happens automatic. Okay, but now the problem with downcasting. Okay, if I draw a line, so if I take a number, is there any guarantee that that number will be an integer number? Is there any guarantee that that number must be a float number? No, right? So there is no guarantee that that number will be a prime number or other kind of number, right? So downcasting, so whenever we do downcasting is not obvious. But upcasting, Upcasting is obvious. So upcasting is automatic. You understand upcasting? But downcasting is not obvious. So there are sometimes it may arise problem for downcasting. You understand? Everyone understand this? Okay, thank you. So if you understand this and if you can remember this, then you will never forget this. Upcasting or downcasting. Upcasting, remember that up arrow. Okay, so it is obvious. Okay, and downcasting is down arrow. That means if I pick up a number, there is no guarantee that that number will be integer or float or double. It may be, right? Okay, but if we concise, for instance, we take downcasting then with a fraction of numbers. Says if we take subset of numbers, whole numbers, if we take subset of numbers, then maybe the integer, right? An integer set, number of integer is a subset of real number, right? Okay. So if we remember this, then it will be easier for us to understand downcasting. Okay, so let us see that. So we said that a minute ago, we said that n1 and n2 are numbers. Okay, and we have integer I equal to 5 and double d equal to 2.5. Now if we convert this, say if I say I equal to n, it will give you an error. Okay, so because I showed that there is no guarantee that this is that n will be an integer number. Don't mislead, because the assignment operator, it does what it does. It pick up the right side value and put the left side. So assignment operator does this way. So it takes the value from right side and put it to the left side operand. Okay. So here it will show an error because there is no guarantee that our n number will be an integer number. A minute ago we showed that, right? Okay, and if we say n2, there is no guarantee that this n1 is also, or n1 or n also will be a double. No guarantee, right? Just we showed here a second ago. So if we say, if we take an integer value, if we take a number, then there is no guarantee that that will be an integer or that will be a float or that will be double, right? So this is why the error is coming here. So these two lines, you see that here. So errors coming over here. You understand from the figure, from the picture, from the drawing, you see that. You understand, okay? So how to resolve this issue? There is only one way to resolve this issue, that we need to do explicit typecasting. Okay, explicit typecasting means in mathematics we will say that we will take a subset of number to make an integer number, right? If we take a subset of numbers, then we can have an integer number. Okay, so then how do we take subset from the perspective of programming? So that we will do the typecasting. So whatever my n value was, I am converting to an integer number. Okay, then it will be fine. Okay, so this statement will not work, but this statement will work. So what is the difference between the statement in line number 39 and line number 37? Just I converted it to integer type, right? It's explicitly I converted. This is called a downcasting. Okay, and similarly this one. So my type D was double, right? So I need to convert this to double type. This one, the line number 38 and 40. The 38 will work, like if I convert this to downcasting, and if you see that, just I print it over here, and this program will work. You do understand this? Anyone has any question? Okay, yes. No, any type. You want to convert from one type to another type, or you have to enforce that.
So the only way that
You can do explicit type.
but without casting,
You cannot have.
you can upcast without.
Yeah, you can upcast.
And upcasting would be converting from a number to decimal or to double. That's upcasting.
Anytime you can convert. From if like for instance, if you have a subset, so I'm discussing there, right? If you have a subset integer number, right? So any integer number, for instance 5, right? Can you make it as a for instance, integer number is also a subset of decimal number actually. Sorry, I would write this over here. So you can make it 5.0, right? Easily, right? And then this is actually my figure would come over here. Integer would come over here. Actually, integer would come over here. So integer would come over here. So I do some. So in this case, for instance, the typecasting is that we have to ensure that there will be no data loss. So if I make 5 to 5.0, will there be any data loss? No. Right? If I convert 5.9 or 5.1 to 5.0, there will be loss, right? Right? So we have to ensure that there is no data loss. Okay, anyone has any other question? So this is likely critical. Some of you did not give attention to my lecture, I know that, but it is your turn. You can watch this like part of this video, but you will get a test question from this, hopefully in any of the test, and in your life you will be using this. But if you remember my lecture for this part, you will never forget it. You should never forget it. Okay. So if you do not have any question, then I would like to skip. Because I'm done this slide. Module 2 part 2 is done. Anyone has any question? Okay, and that's good. So I'm done in module 2 part 2. Okay, and also in our last lecture I discussed module 2 part 3, right? String operation. I discussed in our last maybe 5 minutes or 5 minutes, 5, 6, 7 minutes. In our last lecture, I discussed like string operations. Okay, so string, for instance, let me recap it quickly. So string is, what is a string? We knew that. So string is string literal is something that is enclosed with double quote. Okay, so string is a character type array. So what is an array? In mathematics, array is a list. So array actually is list. In mathematics, the list comes from a set. So you understand, person, what is the difference between a set and a list?
A set is, no, I don't really know.
Okay, who can give me this difference between a set and a list? What's a set, right? A set of students, a set of books, a set of paintings, right? A set of things, a set of buildings, a set of yes.
Sets are all like one type of thing.
Yes, also list is one type of thing should be.
List is organized.
Okay, set is also organized. Okay, the key difference between a set, yes. No. Yes. Yes. The set does not contain duplicate value. One item exists one time. Okay, but a list, usually a list, numbers, list, we say if a list of numbers, then a number can happen multiple times. Okay? If we say 5, if all students get A, okay, in this course, all students get B, okay, then okay, that's the main difference between a set. A set does not contain duplicate value, but a list contains duplicate value. Okay, the concept of array came from the list. Okay, so list. So this is a list. That means it's a list of characters. Right? C is a character, O is a character, M is a character, P is a character. Each of the characterized this is a string, and you see that this is a one-dimensional array. So the array, you will learn this a few weeks later, what is an array. So an array is a list. An array, it start with index 0, and it start with it goes all the way to the last element, the length -1. So in human language and natural language, when we start counting something, we start counting 1 2 3 4 5, right? This is right. But an electronic device count from 0, counting from 0. People invented numbers 1 2 3 4 5 to 9 first, and then later people, mathematicians, they invented 0. 0 has nothing, no value, real value, but it has a lot of implication, right? If I have a number 1 million, if I give 1 0 in the beginning at the right side, then I will have 10 million, right? Usually a 0 has no value, okay? Then but is 0 is considered as an even or odd? 0 is an even number or an odd number? Neither, but it is considered as an even number. If 0 is put on the right side of a number, then the number becomes an even, right? Any number put on the right side 0, then the number is even number, right? So who invented 0? Okay. So 0 is history of invention of 0. It is not my task, but I wanted to, just curiosity. If I say, I want to say Wikipedia maybe. Okay. So Mesopotamia, so like today's Iraq, that area, Iran, that area is around 3 BC before. Okay, that Wikipedia should have good information. Okay, who invented 0? Okay. So it's an Egyptian numeral, Babylonians. I don't know. Okay. Just I have curiosity. I will read it sometime. Okay. What I was going to do. So, but the computer system start counting from 0. All electronic devices counted from 0. So if we say, give me 10 numbers, so if 1 to 10 is 10 numbers, but if we start from 0 to 9 is 10 numbers, right? So all arrays indices start with, this is the address or index of the array, okay? Position. Start with 0 and it goes to the last, length -1. So 0 to 9, that means there are 10 numbers over here. So here in array decoration, so a string is a kind of character array, because whenever we say hello world or hello something, so everything is say hello is a sum of character, HELLO, right? So for instance, this is the decoration in Java. So if we say a character array ARR, say AR0 will be J, if we assign value J and the next one A, then B and A, so then output we will get, so if we print output and we will get Java JAVA in one line because there is no ln. So this is the decoration in array declaration in Java, and this is also in C#, is little almost same, but in C++ it is quite different. Okay, so you will learn that later, but for now I like everybody to practice this program. Okay, So I like everybody to practice this program because string, as we discussed from our previous hello world program, right? We discussed our hello world program in one time over here. Remember that? It's a hello world. So hello world 5 maybe, right? We discussed hello world 5, this one in your section. Okay, so it's hello world, so it's w, this is also a string. And then in the modern programming languages, or there are array, string is considered as a built-in data type but not primitive, and there are all programs deal with string operation. You see that this application, it has on the top menu, say Chrome, File, Edit, View, History, Bookmarks. These are the menu, right? So each menu, for instance, File, it has some sub-menus, right? If I click on File, you see that sub-menu. Some of these have also more items. These are another sub-menus. So these are handled easily with string. So string has a lot of use in programming, okay? So it will be better, you will learn that string operation later at the end of this course. But for now, if you please that remember these steps. So there are some length method. It is used to determine the length of a string, and to uppercase, that is to convert a string into or in uppercase, to lowercase, subset, substring. So there are some string operation methods over here. Okay, so I like everybody practice these few programs, this string operation program. This is in Java, and also this will be in C#, same thing, and this will be in C++. So I like everybody to practice this program. Okay, and so far I gave you some homework, right? How many total will be? About 10 to 12 programs total. So I asked everybody to practice this 10 to 12 programs. And if you practice this program, then what will be the advantages then? The advantage is only one advantage that it will help me that I promise that in this course I will teach you how to walk in the field of programming, right? Okay, the first step is to stand up, right? Before we start walking, we need to confidently stand up. Then we need to start walking, right? So the program is these 12 programs. I asked you to practice. If you practice this 12 programs, maybe I will give it maybe today 3-4 programs from the next slide. Then if you practice these 12 to 15 programs, then you should be able to stand up confidently. Then our next step will be to start walking step by step, 1 step, 2 step, right? Okay? So everybody, if you are behind, yes, so this is the last week. This is the last week, day before you come to our next lecture. So please bring your laptop. Okay? Then we will do some coding, okay? That coding I will walk through. Okay, and then so far I believe that if you practice this 10 to 15 programs, now we are in good shape to stand up confidently. Then we will learn how to start walking. Okay? And this program is one of these programs. Please practice, okay? Anyone has any questions so far? Okay, so now we are good. And now we have 40 more minutes. I'm fine with that. And then today we will start module 3, selection statement. Okay. So you see there are 56 slides. So 56 minutes should be enough to discuss all these 56 slides. Okay, today I will go quickly and let us see if I can. I think I should be able to go through all of these slides, because if you understand the previous 10 problems that I asked you to practice, then this should be a good startup. So we are familiar with the print and printf statement, right? Okay. So far what we have learned that if I have a program is written with some statements, right? If I have a program and if there is nothing stated explicitly, there is nothing stated, then the program statement will be executed from starting from the main method and from top to bottom only one time. This is the normal procedure, right? But sometimes we may need to execute some or one statement more than one time. We will discuss that looping, that is called looping. We will discuss that next in our next module. But sometimes we may need to execute one statement, or we may need to execute skip a statement, right? We may need to jump from one position to another position of a program, or based on the output of a statement or result of a statement, we may decide which of the following statements we will execute or not. Okay, this is called decision. Okay, in order to execute our algorithm and solve our problem, a decision statement is always important and is needed. So in order to decide which statements will be executed or not, actually there are mainly two decision statements. Like number is one is called if statement. If has also two other siblings, if and if else. And switch statement. I think it's out of battery. So it is out of charge. So people who are in the back, can you please give me a favor? Can you please come forward? I'm tired. I cannot speak loudly. Okay. Sorry, microphone battery is down. So. Okay. So actually, so if, else, and if, else, if, these are the siblings of if, extended version of ifs. Okay, and then mainly then we have if and switch statement. So in our daily life, so we actually we are familiar with actually if, else, if. You are familiar with in natural language. This is straightforward. Nothing is complicated. Okay. So let us see that control flow. So we discuss this. So unless otherwise decided, our statement go one by one. Okay. So okay. So this is a diagram. This is a flowchart diagram. It says, for instance, if you are charged whether you have broken something or not. So if you will ask the question, did you break that? So if you said no, right? Then they may ask you, are you lying? If you say yes, then they will ask you, okay. But if you did not really break that, then you say no, right? Then it will come this way. And for instance, at the end, maybe if you really did not break that, then you will not be asked any charge. But if you break that, maybe you will ask for a compensation or maybe forgiveness. So this is a flow chart. For instance, this is the starting point and this is the ending point. Okay, there's a mistake over here. It should be an oval. Okay, but this one we are focusing here. This one, diamonds. These diamonds, all of these diamonds, this represent what is called the decision statement. At this point, there is a question mark. That means we will have result of this question, and the result will be Boolean. Boolean means either true or false value, right? and this in our natural language this gives us either yes or no answer. So if it is yes, that means true, and it is no, that means false, right? Okay, so yes is equivalent to true and no is equivalent to false. Okay, so that means all of these conditional, these are the checking, condition checking, these will give us either a true or a false value, that is a Boolean result. Okay, so all of the like these are the selection statement I told you a second ago. Okay, so if, else if and else if, so these all of this if, okay, works with a Boolean value, Boolean result. So how does Boolean value is calculated or found? So sometime it may be given directly, or sometime it may be evaluated through a relational operator, a relational expression of the relational expression. A relational expression, that means there are some operators, these are called relational operators, that give us only true or false value, Boolean value. So for instance, the greater than sign, we are familiar with greater than sign, right? If say 5 is greater than 2, yes, right? So in natural language it says yes, and in computer language it will say true. Okay, and then this is not equal, then this is not equal, this is not, and this is greater or equal, this is less or equal. This thing is, we need to give attention. Equal sign, this is the actual equal operator. In computer programming we'll see equal operator, but the one equal sign, that we call assignment operator. Do not be misled with the assignment operator with the equality operator. Okay, this operator gives us either true or false value. Okay, so we are familiar with this, and what happens, so you see that directional operator gives us only true or false value. If we say 5 is greater than 3, right? If it is true, then we will get true value. If it is result is yes, then we will get true value. If its result is no, then it will give false value. So it says 6 not equal to 6. Is this true? 6 not equal to 6? No, right? So result is false. So here true equal 4 less than or equal to. So actually this side will be, right side will be executed first. So then it will give us what will be my value for the right side? 4 less or equal to 2. It will give us true or false value. Carson? False, right? So then we will check whether true equal to false. Is true equal to false? No. So the final result is false. Okay. If C, actually it gives the ASCII code, C value, ASCII value of C is not equal to ASCII value of B, is true. Okay, not false equal to true, not true equal to false. Okay, so we are familiar with this. Okay, so relational operators, for instance, so also these are the relational operators. Okay, and there are also another kind of operator that is called logical operators. So there are is there any electrical engineering student over here? Anyone major electrical engineering? No? Okay, so this should be like familiar with, you should be familiar with logic circuit. Okay, for instance, okay, logic circuit. If I have a, for instance, battery, so if I have a battery over here, electric battery, okay, and I have here, there is a switch over here A, and there is another switch over here B, and if I have a light somewhere here, for instance, anywhere, okay, so will the light turn on if either A or B switches, either of these is off? The light turn on? No, right? In order to turn the light on, I need to get both A and B on, right? Right? So that means in order to get a true result, I need both A and B true. Otherwise, if either A or B is turned off or false, then this will be false or off. Okay, so this is a series circuit, right? You should understand this in physics, right? In physics you should have seen this, okay, but this is the logical and gate, and then so the corresponding operator, there is a corresponding operator, this is 2 ampersand together, this is logical AND operation. In some languages they write AND like this way, A and D, but the languages we are discussing here, AND will be 2 ampersand together, okay. But if I have a if I have a battery, so if I have a battery over here like this, and I have switch A over here, and then maybe switch B over here, and then the light is here, so this is my light, okay, it doesn't work well, so this light will turn on. You see that either A, switch A, or B, or both if it is on, right? Then the light will turn on, right? Either this A is on or B is on, or both is on, right? Then light. So this is called logical OR operator. Sorry. My battery, I forgot. Okay, that's good. So this is logical OR operation, okay. This is logical OR operation. So logical OR operation, if either one is true, either A or B is true, then result will get true. But in order to get result false, we need to get both A or B false, okay. So in most of the programming languages we use 2 vertical bars to express the logical OR operation. In some languages like Python, they write OR like in English, but we will use these 2 vertical bars to express OR operations, okay. So you understand OR. So if you have OR, so either if I have 3 switches, 4 switches, 10 switches, 100 switches, right? If at least one of them is true, then entire result is true, right? For AND operation, in order to be result to be true, all must be true. Understand? Okay, so this is called logical operators, okay. The logical expression we discuss this. We will use this in order to 2 kinds of operators, relational operators and logical operator, to find the value of the condition that we will put with after if, okay. These like I'm coming back here soon. So the logical operator, so for the if, let us see how it works, the if statements. So after if statement is followed by a condition. The condition will be either relational or logical. Okay, we just understood two kinds of operations: relationals, that says that finds relation between two operands, either true or false result, and it gets the another kind that we discussed this, right? Like Boolean like this we discussed. Okay, so no matter, so whatever, for instance, if there is the condition over here, so the final will be, see that this is the something and this is something must within it says and. So the final result will be here either true or false, nothing else. So a relational expression or a logical expression, sometimes it's called a Boolean expression. That gives, a Boolean expression gives only either true or false value, nothing else. Understand? So we will use that Boolean expression, okay, in order to decide or for all logical if, else if, for those expression. Okay, so for instance, this is the block diagram of if statements. So this will be a condition over here. So the condition, it will be evaluated the condition. If condition is true, then the statement will be executed. If the condition is false, then this statement will be skipped. Then it will go bypass this. It will be detour. Okay. So the format of if statement is very simple. So if, after if, there will be a condition. Remember that the condition will be a Boolean condition, Boolean expression. Okay, that will give either true or false value, nothing else. We remember. Okay, and this then is required for in pseudocode format, but in most of the programming languages, then is implicit. We do not need then. Okay, so that means if the condition is true, then we will execute the statement here. If the condition is false, then we will skip this, just skip it. Okay, so let us see a problem. So this problem says that write a program to convert user input of Celsius temperature to Fahrenheit. Take a user input in Celsius and convert it to Fahrenheit. Maybe there is a problem previous week I asked you to give practice. Okay, the same thing. Then display the converted temperature to the user. Issue a heat warning if temperature is at least 90 degree Fahrenheit. Okay, so what this program will be is asking, like for instance this is the pseudocode format. You will taking the, okay, so this is Java and C++ format. So you will take an input in Celsius, read input Celsius, and you will convert this Celsius temperature to Fahrenheit. So in our last lecture I told you what is the conversion formula for temperature. The conversion formula is C by 5 equal to F minus 32 by 9, right? Okay, so here this formula we will implement to convert either from Fahrenheit to centigrade or centigrade to Fahrenheit. So whenever the input you have ready-made, you will put that variable on the right side, and whatever you will convert, that will put on the left side. Okay, so here, so if I take Celsius temperature, then I will follow this. Okay, then this is the if condition. If we will take an input in Celsius and we will convert in Fahrenheit. If my Fahrenheit is greater or equal to 90 degree, then I will give a hot warning over here. Okay, so this is pretty straightforward. Anyone has any question here? This is simple, right? So this is in pseudocode, and then previous programs in Java and C# and C++ format. You just need to change the read. Yes. Okay, in pseudocode you need end if, but in program this is the end. This square bracket means the end. Okay, but in pseudocode format, good question though. So in pseudocode you need to put end if. Then you know braces over here in pseudocode. Okay. Anyone has any other question? Yes. Okay, I will go through this in a minute. So if statement, this is the if body. If body, if is only one single line of statement, then this square bracket is optional. You can give it. Okay, that means actually block. If it's a block stuff. If this block is enclosed consists only one statement, then this is optional. But if there are more than one statement, then this is compulsory. Okay, and for pseudocode format, whatever how no matter, so at the end of the block you will give end if. Okay, so if you write pseudocode, remember that if you do not write this end if, you will lose point. And in pseudocode you have then, but in actual program code there is no then. Then since pseudocode is in natural language, right? If we say if you come to my office, then I will give you time. Yeah. In natural language we say then, but in programming language then is implicit. Okay, anyone has any other question? That's good. So these conditions, so for instance, let us it is a little bit improved. So it says if heat is greater than 90, greater or equal to 90, or less equal to Fahrenheit and less equal to 20, then both side extreme, right? This is too cold and this is too hot, right? So we can have, this is logical OR operator, right? That means in order to get OR this true, I need to be true either this part or this part. If either of these, either this part is true or this part is true or both is true, then we will go. But in the temperature it cannot go both way, right? Either all will be, it will go either side. Okay. So I like everybody to practice this program. Okay, so this is the program. So now let us go to the if else. If else is very simple, like more likely as if, but in if statement we just stated that if the condition is met, then it will execute this body, right? So we did not tell that what will happen if the condition does not meet, right? If the condition is false, right? So that part will go to our else part. Okay, if the condition will be given only with if, and if the condition is true, then it will execute this part and it will skip this part. And if the condition is false, then it will be execute this part and then it will skip this part and it will go outside. For instance, in natural language, if say if you come to my office, then I will go with you for a dinner or lunch, otherwise or else I will go alone, right? So there may have only one else. So else is not required, but if there is else, then only one else, right? Okay, but sometime if there are more than one conditions, okay, I'm coming with, then we can have multiple if statements, if a condition. So this is the flowchart for if else, right? So if the condition is true, then it will execute this block 1, and if the condition is false, then it will execute the statement block 2, another statement block. So which is statement block 2? This is the statement block 2. Actually this is the statement block 2. Okay, and let us redefine the previous program. Okay, so this program is similar to that previous program, but it has the use of else statement. So the same thing is same, and this is write a program and the issue a heat warning if the temperature is at least 90 degree Fahrenheit. Okay. So let us see this. For instance, if the temperature is greater than 90 degrees, say that this will be heat warning. Otherwise, it will say there is no extreme heat. Okay, else is condition over here. Okay, so in pseudocode format we need then, but in actual program code we do not need then. But what we will do, we will enclose the body block within curly brace. If it is a single statement, then this curly brace is optional. Okay, but if there are more than one statement, then you must enclose with curly brace. Okay, and this is the else statement. So anyone has any questions so far? Everybody is good? This is very simple. I like everybody please practice this program. Okay, only one program. You start with one program and then you will see that you will learn all of the selection statements. Okay, the last one for if. Okay, if there are multiple conditions. Okay, if a program or problem requires to check multiple conditions, then the first condition, okay, the multiple conditions, that if there are multiple conditions, maybe there are different way that one conditions go with another condition. We will discuss that later, next lecture. But for instance, if condition 1, 2 and 3, these conditions are separate. Okay. Okay, for instance, if I ask you, if Carson, if you come to my office, then I will go with you. Okay, what is your name? Megan? Lycan. Okay, then if you say if Lycan comes to my office, then I will go with her. And what is your name? Okay, if she comes with me, then I will go with her. Okay, so that means the condition, his condition is not connected with her condition, right? And her condition is not connected with this condition. That means the condition, if the conditions are separated, not linked with each other. Okay, so then in that case we will use the condition. The first condition will go if, and the other subsequent conditions will go else if. Okay, and or if all of the conditions do not meet, then we will go to the else block. So in pseudocode format, you see that there are thens in each of the block after if. Okay, but in actual program code we do not. This is the flowchart. In actual program code we do not have, this is the pseudocode, we do not have then, but we have enclosing parenthesis. Okay, so this is the condition. For instance, we say if heat Fahrenheit is greater or equal to 90, then we will say it is extremely hot. If it is greater than 80, that means if it does not meet, then it will come here. If it does not meet, if it meets, then it will not come to this. Okay, so if it is greater than 80, that means is less than 90 but greater than 80, then it will go to this condition. Okay, so these are very like straightforward. I like everybody to practice. Okay, so including this, there will be total 15 programs so far. I am asking everybody to practice before you come to our next lecture. If you practice this program, you will be good in test 1. If you do not practice this program, your test 1 will be the worst test. Okay, so here you see the condition over here. The first condition is check. Okay, if the condition then is false, then it go to the second condition. If the second condition is false, then it will check for third condition. If any of the condition is true, then it will not go to the other condition. Okay, because these conditions are separated, right? Not linked within. Okay, we will discuss like more complicated conditions. Okay, then nested condition later next week. Okay, so I like everybody. So this is the second version little bit complicated version of the previous program. So I like everybody to practice this program. Okay, anyone has any questions so far? How many minutes I do have? That's good. I have still 10 minutes, and the last thing I will discuss, switch statement. But before I go to the switch statement, let me take a 1 minute break and see if anyone has any question. Some languages like Python, Scala, F#, they do not have curly brace. They have indentation. To tab, just tab or space bar at the beginning. We are not discussing those languages, so we are not worried about those. But these languages we use curly brace, okay, to identify a block. If there is one statement for a block, then curly brace is optional. Okay, if there is more than one statement, then this is required. So everybody is good? Okay, that's good question. So it is Fahrenheit, okay? So Fahrenheit degree, so this double, right? The double I discussed it needs to be 0.0. Otherwise it will consider as a whole number, integer number. Good question, right? Thank you. So double, initially we are taking Fahrenheit. So maybe I'm taking, if I take temperature in Fahrenheit, you may say 92.5, 92.7, right? So in more accurate format, then we need Fahrenheit. Anyone has any other question? Okay. The switch statement is the last one we will discuss, but it is a little bit complicated. Okay. Switch statement is an alternative format of if, else if, else if. If the last one, right? We discussed this one. So switch is the alternative version of this if, else if, but it is straightforward. It's readability. It has like better readability to understand, but it is a little bit complicated. Okay, first of all, so a switch statement work with a variable. Okay, for instance, at the beginning or before we start a switch, we need a variable. Based on the value of this variable, it will go inside these cases, either one or some of these cases. Okay, for instance, if I create a variable and the variable has value equal to 1, then it will execute this statement block. If the value is 2, then it will execute this statement. If my variable value is 3, then it will execute statement. If my variable has value neither of this, then it will go to the default statement. Default block is like else. In our if else we use else, right? If none of the conditions meet, right, then we will go to the else block. And here, then if none of the cases meet, then we will go to the default statement. So this part up to this is straightforward, but the complication comes here with the break statement. Okay, in some languages, give attention please, listen to me. In some languages, break is optional, like Java or C++. But in some other languages like C#, break is required. Okay, the break means whenever it executes this block, if the condition is met, the case met 1, and after it executes this statement, it will go outside the switch. It will not go to the next. It will not look at for the next case. Okay. But if its break is up, if it's omitted, it's not given, then still it will be checking this condition. It will be going this condition. Okay. So Java has ability to have either have break or not break, but also in pseudocode. Is this the pseudocode format? Okay, in your test you are most probably will get some statement with a structure like this, switch statement. And if you get a question like this, first of all give attention whether you have break or not. Okay, if it is break is available, then the result will be one thing. If break, sometimes we may give you intentionally missing break. Okay, that means we want to check whether you remember the statement that if the break is missing, then still it will go to the next statement. You will check the next statement until it finds break. Okay. Anyone has any question? Yes. Okay, C# will tell you that missing break. It will not, program will not compile.
So, like, let's say, in pseudocode, we have to put break.
Yes, in pseudocode, mainly pseudocode. In pseudocode, if you write pseudocode, then you have to explicitly say break. Is here, for instance, let us see this. Okay. So I'm here. So for instance, this condition. So Fahrenheit temperature like divided by 10. So I'm giving condition. So condition if it is 10, right? So if I miss this break intentionally, then it will do this. Also, it will go this. For the next one. So the good way to understand this, please practice this program. Okay. So you have this code right over here. So write this code. So in Java and C# and C++ format. Okay. And sometime use the break and sometime just make the break commented out. And see the effect of your program and see the output. Okay, then you will better understand the missing effect of missing break or having break or not having break. You understand? So this program, for instance, this is the same program that previous exam. For instance, we do give, so whenever we write a program code to determine your letter grade. For instance, if I have missing break over here, if I do not make break, then if you get A, then you also get a B also. Because all students who get A also they get B, right? In order to get an A, you need to get 90% at least, right? So then whenever you get 90%, that means you still get 80% or up, right? Right? And still you get 70% or 60% or 50% up, right? So do you like to get both A, B, C and D, J or only A? So then you need to break. Okay, then whenever you get your grade, then nothing will be checked. So because these are done. Okay, but if your letter grade, if your number is 70 to 79, then letter grade C, right? Then it does not meet. If it does not meet, then it will come to check over here. If it does not meet, then it will come check over here. If it meet, then it will skip this. Okay, so this is my humble request to everybody. So please practice this program. So far maybe I'm giving you 15 programs to practice. Okay, these 15 programs will be your starter. If you understand and practice these 15 programs, then what will happen? Then you will have a good start. At least you will be able to stand up and fill the program confidently. Then our task will be to learn how to walk, right? Start walking. And in our next lecture, please bring your laptop. Okay? And then we will do some live coding and then programming, okay? So anyone has any questions so far? Okay, that's good. So people who are online, anyone has any question? So I see William, Jonathan, Ben. So people who are online, anyone has any question? Oh, 31 people are online. Okay, thank you so much, and you have a good day today and good evening. Thank you so much. You have a question? Thank you so much. Yes. Yeah, you should see now. Go to the what I today or last night I opened the feedback. I published the feedback before the test. Hmm? Oh, that's good. So, okay. For the test and quizzes, if you have disabilities, so please give me a reminder. I get 2 emails for now. I will try to remember, but please give me a reminder. Send me an email before you plan to take your quizzes. Is okay? Are you okay with me? Yes, day before. Okay. And do not start until I reply.